Hi there, I'm glad you're here. Today we're diving into a really useful topic for anyone working with big data, partitioning in Hive. If you've ever wondered how to make your Hive queries run faster, or how to organize huge tables so you only scan the data you need, partitioning is the answer. In this video, I'll explain what partitioning in Hive means, why it's so important, and show you, step by step, how to create and use partition tables with easy examples. Whether you're brand new to Hive or just want to make your data work smarter, you're in the right place. Let's get started. Let's imagine you run an online store, and every time someone places an order, that order gets saved in a huge Hive table. Over the years, you collect billions of these orders. Now let's say your manager asks for all the orders from January 2024. You only want that month's data, not everything. If your Hive table isn't organized or partitioned, Hive has to look through every single order, across all years and months. That takes a lot of time and computer power. But if you set up your table to be partitioned by year and month, Hive knows exactly where to look. It jumps straight to the folder for 2024 in January, skipping all the rest. This makes your search much faster and saves resources. That's the power of partitioning in Hive. Partitioning in Hive is like organizing a huge library. Instead of putting all the books in one big pile, you sort them into shelves by genre, author, or year. In Hive, this means dividing a large table into smaller logical parts based on the values of certain columns. Each partition in Hive is stored as a separate folder in HDFS, just like each genre in a library has its own shelf. This makes it easy to find only the books, or data, you need. For example, let's look at this code. Create table sales partitioned by year-month. This tells Hive to organize sales data by year and month. When you run a query for January 2024, Hive only looks in the folder for year 2024 and month 01, instead of searching the whole table. This makes your queries much faster. Let's talk about the two main types of partitions in Hive, static and dynamic. Think of partitions like organizing your closet. Sometimes you sort clothes yourself, and sometimes you let a smart system do it for you. First, static partitioning. Here, you tell Hive exactly where each piece of data belongs, just like putting your winter jackets on the top shelf yourself. Let's look at the complete code for creating a partitioned table in Hive. Here it is on the screen. We'll go through each part together, line by line, so you understand exactly what it does. First, we start with create table sales. This means we're making a new table called sales. Inside the parentheses, we define the columns. Product string, amount int. This sets up two columns, one for the product name and one for the amount. Next, partition by year inty, month int. This tells Hive to organize the data by year and month, creating separate folders for each. Finally, stored as Parquet. This means the data will be saved in the efficient Parquet format, which is great for big data. Next, partition by, open parenthesis, year inty, month inty, close parenthesis. This tells Hive to organize the data by year and month, like having separate drawers for each year and month. Finally, stored as Parquet. This just means the data will be saved in the Parquet format, which is efficient for big data. When loading data into a static partition, you use a command like load data in path, /data/sales, _jan2024.csv, into table sales partition. Year = 2024, month = 01. Here, you're telling Hive, put this file in the folder for January 2024. So, with static partitioning, you always specify the exact partition for your data. It's like labeling every box before putting it on the shelf. Now let's talk about dynamic partitioning. Here, Hive figures out the right partition for each row automatically, like a smart closet that sorts your clothes for you. To enable dynamic partitioning, you set two options. Set hive.exec.dynamic.partition = true, and set hive.exec.dynamic.partition.mode = non-strict. This tells Hive, go ahead and create partitions as needed. Then you can insert data dynamically with a command like insert into table sales. Partition year-month. Select product, amount, year, month from sales _ staging. Hive looks at each row and puts it in the right folder automatically. This is like dropping all your clothes in a bin, and the closet sorts them into the right drawers for you. No extra effort needed. You can also partition by more than one column, like year and month, to make your data even more organized. For example, in HDFS, you might see folders like /sales/year = 2023/month = 01/ or /sales/year = 2024/month = 01/. Each folder holds only the data for that specific time period. This is super helpful for time series data, where you often want to look at just 1 month or year at a time. Partitioning keeps things neat and makes queries much faster. Let's walk through how to create and load data into a partition table in Hive step by step. Step 1, create a partition table. The code is create table employee, ID, INT, name string, salary float, partitioned by department string stored as text file. This command creates a table called employee with columns for ID, name, and salary. The table is partitioned by the department, which means data will be organized by department for faster queries. Step 2, add partitions and load data. First, add a partition for the HR department. The code is alter table employee, add partition, dep.jar. This tells Hive to create a folder for the HR department, so data for HR will be stored separately. Next, add a partition for the IT department. The code is alter table employee, add partition, dep.it. This creates a separate folder for IT, so IT data is also organized by department. Now let's load data into these partitions. The code is load data in path, /data/HR_data.csv, into table employee partition, dep.hr. This command loads the HR data file into the HR partition of the employee table. Similarly, load it data with load data in path, /data/it_data.csv, into table, employee partition, dep.it. This puts the IT data into the IT partition, keeping everything organized. Step 3, query the partition table. The code is select from employee where dep.r. This query only scans the HR partition, not the whole table, so it's much faster and more efficient. Let's quickly recap what we've learned about partitioning in Hive. By breaking big tables into smaller organized pieces, your queries can run much faster and more efficiently. Partitioning is especially helpful when you often filter by columns like date or department. It saves time and resources, making your data work smarter for you. Just a quick tip, don't go overboard with partitions. Too many can create lots of tiny files, which can slow things down. In our next video, we'll dive into bucketing in Hive, a great companion to partitioning for even better performance. Stay tuned, thanks for watching. If you found this helpful, don't forget to like and subscribe. See you in the next lesson.